Hello, here I am going to discuss today about the thin cylinder. So in thin cylinder, what we'll discuss, that is the topics that to be covered in today's lecture is what is thin cylinder, how does it differs from the thick cylinder, then what are the stresses induced in the thin cylinder because of which the cylinder can burst, then the expression for hoop stress, expression for longitudinal stress, and also we'll derive the expression for maximum shear stress. Now look at this. What is thin cylinder? Thin cylinder is a cylinder whose wall of the thickness is less than 1/20th of its internal diameter. 1/20th of its internal diameter thickness is less than. And the thick cylinder is a cylinder whose wall of the thickness is greater than 1/20th of its internal diameter. This is the basic difference. Now look at this figure. This is the thin cylinder, and inside the cylinder the fluid or the liquids are there, and this is the P at the internal pressure of the fluid that is acting on all the surfaces of the cylinder. D is the internal diameter and T is the thickness, so the external diameter will be D plus 2T, and small l is the length of the cylinder. Now if you take the cross section, so this is the cross section, circular section is there. The pressures of the fluids are acting on the circumference of the cylinder. So a thin cylinder bursts because of the following types of stresses. One is called the circumferential stress, another is called the longitudinal stress. Because of these two stresses, the cylinder can burst. Now look at these figures. There is a figure 1, this one. The stress acting along the circumference of the cylinder is called the circumferential stress, whereas the stress acting along the length of the cylinder, that is in the longitudinal direction, is known as the longitudinal stress. That is, see the circumference, this one is circumference. So if the stress is acting on the circumference, then it is called circumferential stress or hoop stress. And if stress is acting along longitudinal, along the length of the cylinder, then it is called the longitudinal stress. See, there is a longitudinal axis. So if the stress acts along the longitudinal axis, then it is called the longitudinal stress. And if the stress acting along the circumference of the cylinder, then it is called the hoop stress or the circumferential stress. Now, how the thin cylinder burst because of these stresses? See, the cylinder will burst or into we have the two parts because of this hoop stress. That is, it will burst along the length. And see in this figure here, because of the longitudinal stress, the cylinder will be divided into two parts, or it will burst because of the longitudinal stress. So from the diagram, it is clear what is longitudinal stress and what is hoop stress. Now, see, in thin cylinder, this is the circumferential stress, how I have calculated. Look at this. If sigma c is the circumferential stress, suppose sigma c is the circumferential stress. Now this stress, because of this stress, what will be the force, resisting force? We know the force is equal to stress multiplied by area. Now we have to see in which area this stress sigma c will act. This sigma c will act in this area C. This is the length dl and thickness T. So dl multiplied by T, and here is also dl multiplied by T. So that means 2 times of T into dl is the area in which the sigma c acts. So we can easily find out the resisting force is equal to 2 sigma c T into dl. Now what is the bursting force? What is the bursting force? Because of which force the cylinder burst? Cylinder burst because of the force P into dl. P is the pressure of the fluid. Cylinder burst because of the pressure of the fluid. Now pressure acts into area, small d into dl. What is small d? Small d is the internal diameter. This is the internal diameter. So the area will be small d multiplied by dl. Small d this is the small d. I'm just showing you this. This is small d, and this is your dl. So these are the area in which the pressure P acts and the force will be P into dl. Now for equilibrium, these two must be equal. That is 2 sigma c T dTl, T into dl equal to P into D into dl. So dl will cancel out. Then sigma c is equal to Pd by 2d. This is the circumferential stress acting on the thin cylinder. This is the expression of circumferential stress. Now, how will you find out the longitudinal stress? Now see longitudinal stress. For longitudinal stress, what will happen? See, internal pressure. What is internal pressure? Internal pressure is P. And the projected area means the pressure acting on this area. This is circular section. So the internal diameter is D. So the pressure acts on area pi by 4 d square. So internal pressure multiplied by projected area is pi by 4 d square. This is one force. This should be equal to longitudinal stress. That is, I have taken sigma L and the resisting area. Now longitudinal stress will act on the circumference of this area. So circumference is pi, d is the length and t is the thickness. So pi d into t. So sigma L into pi dt. If we equate this, then we will get sigma 1 is equal to Pd by 4t. So this is the expression of longitudinal stress. So from these two relations, we can find longitudinal stress is equal to half of the Hope stress. So this is one relation. Longitudinal stress is equal to half of the Hope stress. So these two relations you have to remember in order to solve the numerical problem. Now, maximum shear stress. See, there are two types of stresses are there in case of thin cylinder. One is called the Hope stress, that is circumferential stress. Another is called the longitudinal stress. Now, these two stresses are normal and act perpendicular to each other. If you see in the earlier diagram, these two stresses will act. This is perpendicular to the plane, and see, this is also perpendicular. So these two stresses acts perpendicular to each other. So that means both the stresses are normal stresses. So maximum shear stresses, since two stresses are there, we know the maximum shear stress sigma c minus sigma L by 2. So sigma c, that is the Hoop stress, is Pd by 2t, and longitudinal stress is Pd by 4t divided by 2. So ultimately we are getting maximum shear stress is equal to Pd by 8t. Pd by 8t. Okay. So this is the maximum shear stress. So look at this figure. Suppose this is a body. Sigma c is Pd by 2t. Sigma c is Pd by 2t. Sigma L is Pd by 4t. Sigma L is Pd by 4t. And what is the shear stress, maximum shear stress? It is Pd by 8. So with this, I have completed. Now, if you find my video good, please share it, subscribe it. Thank you very much.